All right, so I mentioned the factoring approach before. Well, I didn't mention it. We actually worked out a bunch of it, right? Anyway, so the other approach for solving a quadratic equation, ax squared plus bx plus c equals 0, is this guy right here. And I mentioned that in my experience, students tend to end up preferring this approach. And you may be looking at that right now and saying, yikes, seriously? Somebody prefers using that formula to whatever factoring does? Well, here's the neat thing about this quadratic formula. It always works. Like, no matter what the values of A, B, and C are, you can feed them in and it's going to give you answers. Versus the factoring approach where sometimes you got to play around with stuff. And if we're kind of mean on the teacher end of things, it turns out that a clean factorization is just like straight up impossible. You have to have like square roots and stuff flying around inside those parentheses. The quadratic formula, once you've got it down, you can just use it kind of regardless. So I've had a lot of my students, they would just rather have one approach that they know works than sort of the, art versus science. This feels like a science, like you've got the method and you just kind of, iterate on it. The factoring approach can feel more like an art form where you have to try to get a feel for, which, arrangement of numbers ends up working. So anyway, you're welcome to try to factor things if you feel comfortable with the algebra and stuff, but the quadratic formula, it's there and it'll always work for you. Now, and as it turns out, the quadratic formula sometimes will straight up tell you when you can just stop or when you don't really have all that much work to do. Because the big thing that kind of the scariest looking part of the whole thing is that square root term that's sitting, right there. The stuff that's underneath that square root, you'll notice the notes file calls out as a quadratic discriminant. And you can actually use it as kind of an initial flag just to check, maybe I don't need to work on this at all. Because as it turns out, there's three possible cases. When you work out this b squared minus 4ac, it might be positive, it might be 0, or it might be negative. So as it turns out, if what's under there is positive, you can take a square root, and nothing really goes wrong. But the catch is, you've got plus or minus built into this formula here. So plus or minus the square root of that thing. So you technically have two different ways the calculation should end up shaking out. And so I don't usually abbreviate solution like that, but I want to save space. So if the discriminant is positive, you have two real solutions and you kind of need to do the calculation twice, once with the plus, once with the minus. As it turns out, if what's underneath that radical, that discriminant, is actually equal to 0, then more or less that whole thing just kind of goes away, right? The entire square root's gone and all you have is negative b over 2a. So it turns out in that instance, there is one and only one solution. If you were to try to factor the thing out, you actually get like two copies of the same thing. But anyway, so that's nice. You might end up wondering, well, what happens if it's negative? Well, then you've got a negative underneath this square root, and that's not quite as bad as dividing by 0. Like, you can do it. You can take a square root of a negative number, but you might have talked about imaginary numbers or complex numbers in the past. That's what ends up happening. Those aren't what we typically call real number solutions because you have that imaginary number I floating around in there. So the good news is, for the purposes of math of finance, if your discriminant works out to be negative, that may be like the most exciting one of all, because then, hey, I don't have to do any more work. I have no real solutions, and I move on to the next problem. Or if it's the last problem you do, you have a nice, refreshing Sprite. For the record, we're not sponsored by Sprite. Anyway, so let's take a look at a couple of examples here. So the first guy up, we use y as a variable again, just to keep you on your toes, I guess. So we have 2y squared plus y plus 1 equals 0. So now to use the quadratic formula on this thing, we need to identify the values of a, b, and c that go into that formula. And it's, it's quite doable. Our a lives right here. the c is the constant at the end, you might end up kind of freezing and saying, well, wait, there's not a b, because b is supposed to be the coefficient of my like variable not squared, right? But remember, if you don't have a coefficient listed, we assume it's a 1. So I normally won't write that out. I would have just said b equals 1 somewhere. But yeah, so a is 2, b is 1, c is 1. Let's check that discriminant and see what ends up happening. So b squared minus 4ac, well, b is 1 squared minus 4 times 2 times 1. A is 2, c is 1. We work that guy out. 1 squared is just 1. 4 times 2 is 8. 1 minus 8 is negative 7. Well, negative 7 is definitely less than 0. So, good news! We're done! So we just say no real solutions, and we stop. I'll put an exclamation point behind that for emphasis, because it's kind of exciting. We're done. All right, so let's take a look at another example here. So, all right. I want to leave the formula there just so I can point at it, but you've got it in your notes file, so, you know, whichever. All right, so this time around, our quadratic equation looks like the following. We have x squared minus 2x, plus 2x minus 4 equals 0. So that's our quadratic equation. Again, we don't have a coefficient for x. Feel free to imagine that there's a 1 right there, or you can just say a equals 1. That's what I normally do. My b is 2. My c is negative 4. So b squared minus 4ac. In this instance, well, we have 2 squared minus 4 times 1 times negative 4. If you work out the arithmetic this time around, 2 squared is 4. Negative 4 times negative 4 is a positive 16. So 20 is in fact positive this time. Sorry to disappoint you. We've actually got 2 solutions we need to work out. The good news is we've actually already done the nastiest part of this, because now we just have like a square root of 20 sitting right here, and so we can just work out our values separately. All right, so we have x equals, and again, you need to fill in the b and a, but we've already worked out that stuff under the square root. So we'll have negative 2 for the negative b plus square root of 20 all over 2 times a, which 2 times 1 is just 2. So we've got that. Or x equals negative 2 minus the square root of 20 all over 2. And now technically you can try to clean this up if you like, if you're, you know, there's like a perfect square you can factor out here. But for my money, it's perfectly fine just to like, you know, toss this thing into your calculator and, you know, let it do the, you know, do the hard work. Remember, if you're punching it all in at once, enclose that numerator in parentheses so it doesn't only divide this last bit by 2. But when you do this, you should get the following. All right, so when we do this guy, that's definitely going to be negative down here. That one is going to be positive. So I got, accurate to 3 decimal places, 1.236 and negative 3.236. So again, if you wanted to list out your solution set, you know, in the curly braces, you may do so. All right, so again, the formula is kind of intimidating, but if you break it into chunks, it's actually fairly manageable. All right, so I've got one last example I want to take a look at here. So again, this is kind of applications driven. We always end up dropping those in. So we've got this profit function, quadratic form. So let's take a look at that guy. So P of x, I'm going to rearrange it into that ax squared plus bx plus c format because that's kind of how we're going to want it arranged. So negative 0.02x squared, then we'll have plus 100x, then we have minus 600. So here's my a, my b, and my C. Now, for what it's worth, in the interest of time, I'm not going to work out, what the discriminant, ends up being in this instance. Suffice to say, it does end up being positive. So we actually do have two real solutions that pop out of this deal. But in order to figure out, where we have a profit of 500, so I've gotten ahead of myself. I just now realized that. So, because we're not wanting to break even in this problem, we actually want a profit of $500, which seems relatively, low impact. But anyway, so don't have my A, B, and C quite yet. My apologies there. So, all right. So instead, I've got to move everything over. So technically, I've got two of the variables. 0.02x squared plus 100x. 600 minus 500 would actually be negative 1100 equals 0. Now I've got my A, B, and C. Like I said, A and B didn't change. It's just the C is actually substantially more negative. For what it's worth, you still end up with two real solutions. So I'm just going to pop this sucker into the quadratic formula. So negative B, so I have negative 100 plus or minus, when I feed everything in here, I have 100 squared minus 4 times 0.02 times 1100, all over 2 times negative 0.02. Okay. So we got that. Again, you can work this out in chunks like we did in the previous example. I actually tend to type this thing into my calculator in one big burst, so I would want parentheses around the top of this thing, also around the bottom, because if you don't, it divides by 2 and then it's going to multiply by this thing, which is not what you want. So we have two possible x values. If you crank out the arithmetic on this, which again, given time, I have every confidence you can do so, when you work this out, you don't get like clean, integer values. You get an x value of approximately 11 or an x value of approximately 4,989. Now, for what it's worth, no, these things aren't always engineered so they add to some convenient total. That just ended up happening in this instance. If you added them up, you'd get 5,000. Don't expect that to happen all the time. So those are our two production levels. So maybe it turns out if all you're wanting is $500 profit, maybe you can't manage to produce this many of these things. Or you can't expect to sell them or something. Demand is not that high or something. So that's a possibility. The very last question that gets asked on this notes handout, it says, can we reach a profit of more than $500? And we could start digging into more specifics about this, like try to replace this 500 with a 600 or something. For what it's worth, I'm going to tell you right now, the answer is yes, we can do better. The reason why we're actually going to see when we take a look at something else related to this quadratic stuff in our next section.